So again, we're talking about doing recursive formulas and we're deciding how to represent things. We said that we're usually trying to find a term value, all right, which is represented by t at n, and we need to know the pattern. We discovered the pattern was to go up by 3, then by 5, then by 7, which means these values are increasing by 2 every time. Okay. One of the things we can choose, if we want to use a term value from before, we represent it by n minus 1 or n minus 2, depending how many far we want to go back. And n is kind of the value or the term value we're on. And there are 4 in this case. Okay. Now, we actually have to take the value before. Okay, so let's say, again, I'm looking for a value of 10. I got to take the value before. So I got to find Tn minus 1. So that would be my 5 in that case. Mm-hmm. And then I'm going to have to add it to the difference of the two numbers before that. Okay, so if I'm looking for 10, the difference of the two numbers before that plus 2. Well, to represent these two numbers, I use t at n minus 1, subtract the difference, n minus 2, and then we need to add those two values. Okay, so the idea here is, though the formula looks very complex, we can plug our values in. So if we're looking for the value of 10, our third term here, so 10 is equal to, well, the term before that is 5, and we do have that previous information. And we're going to be adding what's here is 5 subtract 2, which is a value of 3, and then we have to add our increase by 2. We know it's going to increase every time. So we get 5 plus, and this is going to be 3 plus 2, which is 5 in this case. So we get a value of 10. And all it really comes down to is trying to represent our pattern using previous numbers in our series formula, right? For instance, our next one here, when we look at this, it really looks like they're taking the value before and just adding 1 to it, whatever it is. And here is the exact same pattern. The only difference is this is a number larger than the guy on top. Okay, so we need to figure out our term value in this one. So our term value in the first one here. Well, we know we can always take the term value from before. Okay, if we can take our term value before this, n minus 1, and we can always add a value of 1 to it to get our next number, right? Mm-hmm. Now, the term value before that, in this case, is going to be 2 over 3, which is the entire value of this. But we don't actually want that entire value, right? So we need to think of a better way to represent this. We know we want just the number on top and just the number on the bottom. So it'd be nice if we could just write, you know, the top one and then the term value from the bottom one, right? T minus 1 plus 1. But that isn't really a way to represent these formulas. So what we're going to try to do is look at their term values. So what term value are we on? This is term 1, this is term 2, term 3, and term 4. Okay, well, because this is a number 1, how can I relate this number 1 to these? Well, I can do that pretty simply. 2 is just a value of 1 greater than 1, and 3 is of a value 2 greater than 1. Okay, so let's say we take the term number, so we're on the first term, and we add 1 to it. That gives us our top value, which is n plus 1. Oops. Okay, n plus 1. And then for our second one, we can take that same term value on the first one, and in the bottom, we just have to increase it by 2. And as those term values increase, for instance, we're on the second one, 2 plus 1 is 3, and 2 plus 2 is 4. And it'll continue this pattern as we go. So really, we want to use either term values or term numbers to represent our recursive formulas here. So let's see if we can build 2 more by looking at patterns. Here's another one that was a little hard for us. We discovered it goes up by 2, then by 2, then by 4, which was a really odd pattern for us, right? And we thought back that, well, maybe what it's doing is it's taking the number beforehand, okay, and adding what it was. So for instance, this is a value of 2, so we take that, and that's what we're going to add by. This was a value of 4, so we take that, and that's what it's going to add by, which would mean the previous number must have been 2 in here, right? So with that being said, okay, we're taking, for instance, if I'm trying to build the value of 6, if I'm trying to build 6, this is the 1, 2, third term, 4. I need that term value. So if I have term value needs to be 6 in this case, well, I'm taking the very first term, which is 2 before it, right? So I'm going, actually, we're taking the value before that, so always represent that, our t at n minus 1, and we're adding the value of the number before that, which in this case is t at n minus 2. So we're essentially just adding the two values beforehand. So the idea is 2 plus 2 is, 2 plus 4 is 6. 4 plus 6 is 10. The next number would be 6 plus 10. We assume would be 16 in this series. So again, we're just figuring out a pattern and showing a way to represent it. So if we're trying to build 6, we know that the term before was 4, and the term 2 before it was 2. We end up with a value of 6. Works out perfect. In our last one here, we go by 2, then by 6, then by 24. So, and let's write our term numbers. 1, 2, 3, 4. There's probably a couple ways to represent something like this. We'll see if there's any relationship between our term numbers and these values. The first term is 1. To get to 4, I can multiply by 4 or add by 3. Does that help us for the next one? Let's see. 2 times 4 gives us 8, so it doesn't help us. And adding 2 to 3 is 5, so it doesn't help us there. Okay. So let's go into seeing what they increase by. Well, this is going up by 2, then by 6, then by 24. There isn't that great of a relationship even between those, at least not a consistent one. But what I might be doing is see if I can find a relationship between the term number and the amount it's increasing by. For instance, let's say we're on term 3 here. We're trying to create 12. Well, this one went up by 2, the value before that. Okay, and I know 2 and 3 have a relationship that's able to build a value of 6. So maybe what we're doing is we're multiplying by the actual term number we're trying to get to. Okay, so for instance, this is times 3, right? And the next value 4, well, yeah, that's right. 6 times 4 gives us 24. 2 times 3 gives us 6. So that's one way to build this. So how are we going to build this relationship? Well, we're going to get our term value. And we're trying to figure out what to add. Okay, that's what we've decided to focus on. Here we added 2, then 6, then 4. So which means we must always start with the term value before it. So we're going to go with our t at n minus 1. And then we're going to be adding, and the adding is where the tricky part is, how to build the adding part of this formula. Well, it looks like the adding part of this formula, for instance, if we're trying to build 12, the adding part of this formula is we're taking the term number we're on, and we're multiplying it by the difference of the two terms before that. So the two terms before that in our case are t at n minus 1, subtract t at n minus 2, and all multiplied by whatever term value we're on. And whatever term value we happen to be on in this case is our value of n. Those are our term numbers. So again, let's say we're trying to build 12. Well, 12 is equal to the value of 6 plus 6 minus 4, which is 2. And our term value is number 3, which gives us 6 plus 2 times 3, which gives us 6 plus 6, which is 12 in that case. Okay. So those are kind of how we built our two recursive formulas here.